want to calculate the pH of a 1 liter buffer solution containing this many moles of the acid and this many moles of the salt upon the addition of this many moles of a base, and they give me the Ka for the acid. So how am I going to do that? Well, I need to look at a reaction, but not quite rice yet. So the reaction I need to look at is the addition of the base. So I have the base, which we indicate as OH, negative, and then I'm adding that to the acid, and that goes to what? Well, I'm going to have to add an H to the first one and take an H away from the second one, so this goes to water plus the anion of the acid. Now, doing that, we need to look at the before concentration. The very nice thing about this is we have 1 liter, so when we divide everything by 1, we're going to get the same numbers. So for the OH, I didn't have anything, right, because I added to it. But for the acid, I had 0.100. Water, of course, doesn't count. And then for the salt, I had 0.100. Now we need to look at how much did we add. Well, the only thing I added was the base, so that's a plus 0.015. Now, if I add that to the solution, what do I have to do to the acid? Well, that means I'm going to have to take it away. So I'm going to do a minus 0.015. And then over here on the products, I'm going to have to add it. So it's the same principle that we use with the x's. It's just that we're looking at actual numbers for this part. And now I need to look at after. So afterwards, I'm going to add straight down. So this is a negligible, so it's still approximately 0.00. Here I'm going to get 0.085, and over here I'm going to get 0.115. So now I know what the concentrations are after I've added that base. So now we're going to use rice. Remember, if we're looking for pH, we want to have something of the 2 initials given to us that will give us a hydronium ion. So we're going to start with the acid. It is in a solution, right? So I'm going to put it in water. That is in equilibrium with, I'm going to get a hydronium ion and the anion. Now, what are the initial conditions? The initial conditions are what we just found. So for the acid, we found that to be 0.085. Again, water we don't care about. There was no hydronium when we started, right? Because there's no hydronium in this equation. And then for the anion, we have 0.115. So what's the change? Same old, right? We subtract x on the left, and we add x on the right. And then I need to look at it at equilibrium, and I'm going to add straight down when I do that. So I get 0.085 minus x, and 0.115 plus x. So now when I do that, I can now use my equilibrium constant, which they provided for me at 1.8 times 10 to the minus 5th. And that's going to equal my products divided by my reactants. I'm hoping that I can do an approximation, so I'm going to go ahead and just write it with the approximations. And then I'm going to cross multiply and divide. And when I do that, I get 1.3 times 10 to the minus 5th equals x. Now I went ahead and I took that number and divided it by the initial concentration. The number I got is less than 5%, so it was okay to approximate. But I'm not looking for the concentration, I actually want the pH. So if you remember, the pH is the negative log of the hydronium concentration. So I'm going to take the negative log of that 1.3 times 10 to the minus 5th. And when I do that, remember you want 2 numbers after the decimal point, which gives me 4.88.